To review how we can bring the concept of a limit together with the idea of using secants to eventually find the slope of the tangent, we're going to look at two examples, one with numbers and then one with general. So I have this graph of x squared plus 1. That's my green function. And point A is the point that I'm interested in finding the tangent. So if I slide so A and B are essentially in the same spot, the red line now becomes a tangent line. But I can't just use the slope formula because A and B are essentially 1 point. And how do you put 1 point into the slope formula? You would get 0 out of 0, which is not something that we can calculate. So I'm going to separate A and B a little bit. So now AB is definitely a secant. And no matter where I stop B, it's a secant. I'm going to show the coordinates of A. So A is at 1 and 2. I'm going to show the coordinates of B. And if you notice, as I move B, the coordinates will change up here to wherever it falls on. This point C is just if I have a triangle, it allows me to look at rise and run. And as I drag B, B stays on the curve but gets closer and closer and closer to A. And as I discussed at the beginning, if B actually merges with A, the secant line becomes the tangent line. And if B is separate from A, I can calculate slope, which is rise over run, which is the y from point B, subtract the y from point A. That's just another way of saying y2 minus y1 over xb minus xa. And as I grab B and move and change both the coordinates and the slope, I can progressively get closer to A until I get the slope of the tangent. And you can see when I'm really close on this side, it's 1.96, 1.98. On this side, it's 2.03, 2.02. So I'm pretty confident in saying that the slope of the tangent is going to be 2. Now I'm going to repeat that process, but algebraically. So I'm not going to talk about anything in general. So again, whoops, I did not want to move A. I wanted to move B. Sorry about that. We'll get A back at 1, 2. But instead of representing A with an X and a Y, I'm saying A can be at any point I'm interested in. I'm going to call this lowercase a. Then the Y part of that coordinate is whatever I get when I sub A into the function. So F at A. B, if I let H be this horizontal distance between them, if I start at the X coordinate of point A, which is A, and I move forward H or plus H, that gives me the X coordinate of B. Then to find the Y, I would sub A plus H, so it might be 2 plus 0.1 or 2 plus 0.5 into the function to get the Y that goes with B. Now I can do slope because I have 2 points. So y from B or y2 is f at A plus h, y from point 1 or A is f at A, x from point 2 is A plus h, and x from point A is A. I can't really do anything with the top because I'm not going to work with the function until I'm given one. But on the bottom, A plus H minus A equals H. And eventually, if H is the distance between the 2 points, then we want H to become 0, which is why in the next video I will add the limit as H approaches 0 in front of this. So this represents our slope, and the limit as H approaches 0 is going to represent the actual 2 points, A and B, becoming 1, because H is getting smaller and smaller and smaller.